Today, we're doing Math Analysis, Chapter 5, Section 4, the product to sum and the sum to product identities. I'm your host, Dr. D. Okay, so this section, we have two types of identities. One where we're going from a product to a sum, and the other where we're going from a sum to a product. Now, all of these identities basically come from the sum of the angle identities. So cosine of A plus B equals cosine A cosine B minus sine A sine B. Now cosine of A minus B equals cosine A cosine B plus sine A sine B. So we've known that for all our lives. So now what happens is if I add these up, so I'm going to have cosine A plus B plus cosine of A minus B. Well, look what happens. I have cosine A cosine B plus cosine A cosine B, which equals 2 cosine A cosine B, and the sine A sine B cancels. So here I have a product, and here I have a sum. So what I'm going to do is just multiply both sides by 1/2 to get the product alone. So now cosine A cosine B equals 1/2 of cosine of the sum plus cosine of the difference. So there's my first product to sum identity. And once again, this is going to come in handy when we're integrating these, and you don't want to integrate a product, but integrating a sum is a lot simpler. Okay, now we're going to do a similar thing. This time, instead of adding these two, we're going to subtract them. So notice cosine A minus B is cosine cosine plus sine sine, and then subtract cosine A plus B. So now I'm subtracting the cosine A cosine B minus sine A sine B. So when I subtract, I have this minus this equals, now I'm going cosine A cosine B minus cosine A cosine B, so the cosine A cosine B is gone. And I'm left with sine A sine B minus a negative sine A sine B, which makes 2 sine A sine B. And so multiply both sides by 2, and now I have sine A sine B equals 1/2 of this thing. Okay, so it's really simple how we got here, but once again, it's a useful identity when you want to get from a product to a sum, or in this case, a difference. Okay, now, if I do the sine of the sum, then I'm going to end up with sine of A plus B is sine cosine plus sine cosine. And the difference, sine cosine minus sine cosine. Now I'm going to add those two up, and I end up with sine of A plus B plus sine of A minus B. And notice what's going to cancel is the sine B cosine A minus sine B cosine A. What's going to add is the sine A cosine B. So I have two of those, multiply both sides by 1/2. There's my third identity. Now, instead of doing this all over again with subtraction, if we want, notice what we have so far. We have cosine A, cosine B. So we have two cosines. Next one, we have sine A, sine B. Okay, so we did two cosines, then we did two sines. Now we have a sine cosine. Well, the next one that we want would be a sine B cosine A. Now, here's the thing I think this is kind of a redundant one. There's no reason to have both of them. But what you could do if you want to derive this sine B cosine A is you say sine B cosine A is 1/2 of sine of the first angle plus the second angle plus sine of the first angle minus the second angle. Now, the next thing is sine of a negative angle equals the negative sine of the angle. So that means sine of B minus A, if I flip this, I'm making it negative. So I put a negative out in front, negative sine of A minus B. So then what I do is I just go, this is 1/2 sine of A plus B. B plus A plus B, same thing. And instead of plus, this becomes minus the sine of A minus B. So like I said, these two are really the same idea, because if you have two angles, who cares which is A and which is B? They're two different angles, so you would use just the first one. All right. So we've gone from product to sum. Now what if we want to go from sum to product? Okay, this one, we're saying let 2a equal u plus v. And that means a equals u plus v over 2. And then we're going to let 2b equal u minus v. So b equals u minus v over 2. All right, now 2a plus 2b equals u plus v plus u minus v. So notice the v minus v cancels and you're left with 2u. So 2a plus 2b equals 2u. And that means u is going to equal just 1a plus 1b. Likewise, if I go 2a minus 2b, notice I'm going to end up with u minus u, the u's are gone, and v minus a negative v, the v's add. So 2a minus 2b equals 2v. Now if I want 1v, I just divide by 2, so 1v is going to be a minus b. So a, u plus v over 2, b is u minus v over 2, u is a plus b, v is a minus b. All right, now we're ready for action. So we go to sine A cosine B equals 1/2 sine of A plus B plus sine of A minus B. We just got that. Now what we're going to do is we're going to put in place of the A, we're going to put the u plus v over 2. In place of the b, we're going to put the u minus v over 2. Equals sine of a plus b, well, that's sine of u. And sine of a minus b, well, that's sine of v. So now what I have here is the sum. And I want to get the sine of u plus sine of v alone, because I'm trying to go from sum to product. So I multiply both sides by 2, and I end up with sine of u plus sine of v equals 2 sine of u plus v over 2 times cosine of u minus v over 2. Okay, now, like I said, this goes from a sum to a product now. All right, so let's look at all the identities we have. We have product to sum. Sine A, sine B equals 1/2 cosine of the difference minus cosine of the sum. Cosine A, cosine B is 1/2 cosine of the difference plus cosine of the sum. So notice the difference between sine A, sine B, and cosine A, cosine B. The only thing that's different is the sine has a minus here and the cosine has a plus here. Once again, this common thread we're seeing is cosine is the home court, so the cosine gets the plus, and the sine, being the visitor, gets the minus. Okay, now if you have one of each, then sine A cosine B, then we've got 1/2 sine of the sum plus sine of the difference. Okay, now, if we want to go sum to product, well, there are 4 different sums we could have. We could have both sine, we could have both cosine, or we could have the difference in sines or the difference in cosines. So if we have the sum of the sines, then it's 2 sine cosine, u plus v, u minus v. The sum of the cosines is 2 cosine cosine plus minus. Now the difference in sines is going to be 2 sine cosine, just like the sum of the sines, only instead of u plus v, it's u minus v. Instead of u minus v, it's u plus v. So it's the same structure, only you're just changing one sign there. Now, if you have the difference in the cosines, then it's the same sign, but instead of 2 cosine cosine, it's 2 sine, or negative 2 sine sine. So those are all the identities that you need to learn for this section. And should we memorize these?
That's the smartest thing I've ever heard anyone say about anything.
Actually, one thing that you always have an option when there's something to memorize, that is, you could memorize it or you could just remember how to derive it. So if you can go through basically what we just did, if you can remember the cosine of the sum and the cosine of the difference and realize, okay, if I add them, I'm going to end up with one product, and if I subtract them, I'm going to end up with another product. And if I use the sine, then I'm going to end up with the combination of sine and cosine. So if you, that's actually how I do it too. When there's things to memorize that I'd rather derive it so I know, like I'll be able to do that 10 years from now, whereas just remembering all these pluses and minuses and sines and cosines and A's and B's and U's and V's, they'd be gone 10 years from now if I wasn't practicing them. Okay, so what we want to do here to practice what we just learned is rewrite 2 cosine 27x cosine 15x as a sum. Well, remember, the product to sum, we've got cosine cosine, and here's, so cosine cosine equals 1/2 cosine A minus B plus cosine A plus B. So what I really have is 2 cosine 27x cosine 15x equals, so I basically multiplied the left by 2, so I'm going to multiply the right by 2 also, and so that's just going to equal cosine A plus B, or I'm sorry, A minus B. So it's 27x minus 15x, which is 12x, plus cosine of A plus B, 27 plus 15 is 42x. That's it, piece of cake. See, we just went from a product to a sum. That's all we had to do. So the key thing is just remembering those. Okay, now, if y sub 1 equals sine 12 pi x and y sub 2 equals sine 10 pi x. We want to express y sub 1 plus y sub 2 as a product. So, sine of u plus sine of v equals 2 sine u plus v over 2 cosine u minus v over 2. So that's what we're doing up here is, so y sub 1 plus y sub 2 equals 2. Now, notice, what is u? It's 12 pi x. And what is v? It's 10 pi x. So 12 plus 10 is 22 pi x over 2, which is 11 pi x. And cosine u minus v would be 12 pi x minus 10 pi x, which is 2 pi x, over 2, which is pi x. So notice we've now written this sum as a product. Piece of cake. Okay, now take a look at page 241, example 3. I didn't want to write all this on the board, and it's a really interesting problem. When you hit a button on a touchpad phone, you get a tone, but it's not just one tone, it's a combination of tones. So notice on a touch tone phone, the sound created by pressing 5 is produced by combining a sound wave with frequency 1336 cycles per second with another wave having frequency 770 cycles per second. Their respective equations are y sub 1 equals cosine 2 pi 1336t, and y sub 2 equals cosine 2 pi times 770t. So the resultant wave is going to be just y, which equals y sub 1 plus y sub 2. So that equals cosine 2 times 1336 is 2672 pi t, and 2 times 770 is 1540 pi t. Okay, so now what we want to do is turn this into a product. So the cosine u plus cosine v equals this. So what we do then is go, this is 2 cosine. Now, u plus v over 2 would be u plus v over 2. So it's basically going to be 1336 plus 770, which is going to be 2000, and my brain is tired, 2016, but I better make sure of that. So it's 2672 plus 1540 divided by 2. Yeah, 2106. I was right. Amazing. So this is 2 cosine of u plus v over 2, which is 2106 pi t, where t is time. Now we go u minus v over 2, so we're going to go 2672 minus 1540, and that's 1132. and divide that by 2, 566. So there is the waveform in the product form. Yeah, I guess all I had to do was look in the book instead of actually calculating it for myself. Okay, there we are, is your example going from a sum to a product. Okay, one more. This is example 4 on page 241, and this is similar to what you guys have done in physics. We've got a projectile, and the projectile gets tossed upward at some angle. And it's going to go up in a parabolic motion, come back down. The distance it's going to cover is r for range. Now we have the equation that r as a function of theta equals 1/16 v squared, the initial velocity, times sine of that angle times cosine of that angle. So in other words, if we propel something almost straight up, then it's not going to go as far. Or if we propel something almost horizontal, it's not going to go as far either. So what we want to do is we take our initial velocity, 96 feet per second, and the initial angle is going to be 15 degrees, and we want to find out how far that projectile is going to travel. So if r equals 1/16 v squared sine theta cosine theta, what I'm going to do is I'm going to say, since 2 sine theta cosine theta is sine 2 theta, then that means 1 sine theta cosine theta is going to be a half sine 2 theta. So when I put the 1/2 sine 2 theta in, I'm going to multiply 1/2 times 1/16, I get 1/32 times v squared sine 2 theta. Now what I did here, what I accomplished is, I don't have a sine and a cosine, I just have a sine 2 theta. So if velocity is 96 feet per second, theta is 15 degrees, let's just punch that in then. So r is going to equal 1/32 times v squared, which is 96 squared, times sine of 2 theta, which is sine of 2 times 15 is 30 degrees. Well, notice sine of 30 degrees is 1/2, and 1/2 times 1/32 is 1/64. So all we do is square 96, divide by 64. And we get 144. And that is 144 feet. Now, if we want to maximize the range that this is going to travel, we want to find out what the angle is here. So, in order to maximize the range, what we want for theta is for sine 2 theta to be the biggest value it can be. And so for what's the biggest value sine could be? It's 1. So we want sine 2 theta to equal 1. Well, if sine 2 theta equals 1, then 2 theta must equal 90 degrees. And if 2 theta is 90 degrees, then theta is going to end up being 45 degrees. So that says if you want to throw a ball as far as you can possibly throw it, then you want to throw it at a 45-degree angle, and that will get the maximum range. That's it. Have fun with these.
circle